There's nothing in common between our two denominators, so we're going to use their product as our least common denominator. X plus 2 times x plus 4. The first fraction already had an x plus 1 up above, that's a 1, and its denominator got changed. The denominator got multiplied by x plus 4, so the numerator does also. And then in a second fraction you had a plus x plus 3, and down below it got multiplied by an x plus 2, so we do the same thing up above. And maybe you at home right now are kind of itching in your seat going, oh, Mr. T, you made a mistake. I did it on purpose. Notice you can't write it in this way. When we multiplied by x plus 4 up above, it's the whole x plus 1. And I did that on purpose just so I could emphasize it, and maybe you would remember it all the better if I pretended to make a mistake. Tricky me, tricky me. Okay, continuing on. Up above, we actually have two FOIL problems. The first one, x times x is x squared. Outer is 4x, inner is 1x, last is 4. And then we have another FOIL problem, x plus 3 times x plus 2. First term, x squared, outer 2x, inner 3x, last plus 6. And all of this is over the two factors x plus 2 times x plus 4. Up in the numerator, it's time for us to combine like terms. So x squared and x squared make 2x squared. We have 4x and 1x making 5x, 2x and 3x making 5x, so 5x and 5x together add up to 10x. And then the constants 4 and 6 add up to 10 over our two factors x plus 2 and x plus 4. We factor the numerator. 2 can divide out. We're left with x squared plus 5x plus 5. Down below, we keep the x plus 2 times x plus 4. Now that numerator will not factor any further, so that's as far as this problem can go. One last review problem. Complex fractions. We are going to multiply through by the least common denominator of the four many denominators, which is x plus 2 times x minus 2. And we're doing that both on the numerator and denominator. What allows us to do that is the fact that this is something over itself, which is equal to 1, and by the multiplicative identity, anything times 1 is equal to itself, so what we get as our answer will be equivalent to what we started with. We look at each corner of the problem here. In the top left corner, the x plus 2's cancel. We had the x already there. It gets multiplied by the x minus 2 that's left over after the x plus 2's cancel. We then move to the top right. We had a minus 2 there already. After the distribution, the x minus 2's cancel, leaving x plus 2. In the bottom left, we had an x there already. The x plus 2's cancel, leaving x minus 2. Then there's a plus 2. After the x minus 2's cancel, we have an x plus 2 again. Now I know it's very tempting to do some cancellation from numerator to denominator, but nothing will cancel here because of the minus sign and the plus sign right in the center of the numerator and denominator. So we're going to distribute. Up above we get x squared minus 2x minus another 2x minus 4. And down below we've got x squared minus 2x plus 2x plus 4. Okay. Combining like terms up in the numerator gives us x squared minus 4x minus 4. And down below the middle terms cancel, just leaving x squared plus 4. Neither the numerator nor the denominator will factor, so that is our final answer.